In this video, we're going to work some implicit differentiation example problems. We're going to find y prime or dy dx in each one of these equations. Okay, so in the previous couple of videos, we talked about the details on how to do implicit differentiation. So if you want more of the theory on how to do this, go check out those videos. We're just going to go through the problems here. So first, we want to take the derivative of, with respect to x, of the entire equation. Okay, so we're taking the derivative with respect to x of all of this and this. So you can imagine distributing this d dx to each of these terms. So d dx of x squared is 2x. Okay, d dx of this 4xy, we've got one function of x, this 4x. So we'll say minus, and then we'll do this derivative. So we have one function of x, the 4x, and another function of x, the y of x. So the derivative of the first, the derivative with respect to x of 4x is just 4 times the second plus the derivative of the second, y prime, right, times the first. So this derivative minus this derivative plus what is the derivative with respect to x of y squared? And we use the chain rule, right? We've got something squared. What is the derivative with respect to x of some function of x squared? That's 2 times that something times the derivative of that something. Okay? Equals to the dx of 4 is just 0. Okay, so now let's just solve for y prime. Now it's just an algebra problem. Okay, so let's bring all the y prime terms to one side and everything else on the other side. Okay, let's factor out a y prime. Okay, now divide both sides by that 4x minus 2y. All right, we can factor out a 2. So we've got y prime is equal to x minus 2y over 2x minus y. Okay, let's take the derivative with respect to x of this entire equation. So just to make this clear, we've got d dx of that side of the equation, and then we've got d dx of y squared, and okay, so how do we take this derivative? Let's do this first. Well, we need to use the quotient rule. Okay, so the derivative of the top, the quotient rule, because we have a function of x in the numerator and a function of x in the denominator. Y of x is just a function of x. So x plus y of x is a function of x. You see? So at the end of the day, this is just a function of x over another function of x. So the derivative of the top, 2x, times the bottom, minus the derivative of the bottom, the derivative of all of this. The derivative with respect to x of x is 1 plus y prime. That's dy dx. The derivative of the bottom times the top all over the bottom squared. You see? Okay, now here, what is the derivative with respect to x of y squared? That's 2y, y prime, right? The derivative of something, some function of x squared, is 2 times that something times the derivative of that something. Go watch the previous couple of videos where we talk about implicit differentiation. Okay? And then plus 0. All right? So now it's just an algebra problem now. Solve for y prime. Okay, so to solve for y prime, let's expand everything. We'll expand this, expand all of this, and then combine like terms. So 2y, y prime, and then x plus y squared is x squared plus 2xy plus y squared. Okay, now we've got 2x squared plus 2xy, and then we've got minus x squared minus y prime x squared. Okay, so we've got 2y x squared y prime plus plus 4x y squared y prime plus 2y cubed y prime. Okay. Well, no, we've got this 2x squared minus x squared is just x squared plus 2xy minus x squared y prime. Okay, now let's bring all the y prime terms to one side. So we've got 2, we'll put x squared first. X squared y prime, x squared y prime, plus 4x y squared y prime plus 2y cubed y prime plus x squared y prime, and then we have x squared plus 2xy. Now factoring out a y prime, we have 2x squared y plus 4x y squared plus 2y cubed plus x squared is equal to x squared plus 2xy. Now just divide both sides by this term. In the denominator we have 2x squared y plus 4xy squared plus 2y cubed plus x squared, and then in the numerator x squared plus 2xy, and that's y prime. Okay, let's take the derivative of this entire equation. So we've got, just to make sure that this is clear, okay, so let's do each of these derivatives. We've got x plus y is just a function of x, because y is you can think of as a function of x. So we've got the derivative of the square root of something. What is the derivative of the square root of something? 1 over 2 times that something times the derivative of that something. What is the derivative of x plus y? That's 1 plus y prime. Right? The derivative with respect to x of x is just 1. The derivative with respect to x of y is dy dx, y prime. Okay? d dx of x to the fourth, that's just a regular derivative, the power rule. d dx of a function of x to the fourth is just 4 times that function cubed times the derivative of that function. Okay? Now it's just an algebra problem. We just solved for y prime. So we've got okay, let's cross multiply, and if we do that, we've got 8 Okay, let's bring all of the y prime terms to one side. Okay, now factor out a y prime. Okay, now divide by this term here. And that's y prime. Okay, let's take the derivative of this entire equation. We've got the inverse tangent function. Here are the formulas for derivatives of inverse trig functions. So here's arctangent. So we've got arctangent of something. X squared y is just a function of x. The derivative with respect to x of arctangent of something is 1 over 1 plus that something squared. So 1 over 1 plus that something squared, right? Times the derivative of that something. The derivative of x squared y is what? That's a function of x times another function of x. We need to use the product rule. Okay, so the derivative of the first, 2x, times the second, plus derivative of the second times the first. There we go. Okay, is equal to 1, because the derivative with respect to x of x is 1, xy squared. So similar, we use the product rule here. This is different though. This was x squared y, this is xy squared. So the derivative of the first, 1, times the second, plus the derivative of the second. The derivative with respect to x of y squared is 2y y prime times the first. All right, now just solve for y prime. So we've got, and then x to the fourth y squared. Okay, 1 plus y squared plus 2xy y prime. So now let's just cross multiply. Let's do this multiplication here. So we've got 1 plus y squared plus 2xy y prime. Okay, now plus x to the fourth y squared plus x to the fourth y to the fourth plus 2x to the fifth y cubed y prime, okay, is equal to 2xy plus x squared y prime. Okay, now let's bring all of the y prime terms to one side. 2xy y prime plus 2x to the fifth y cubed y prime minus x squared y prime is equal to 2xy minus x to the fourth y to the fourth minus x to the fourth y squared minus 1. Okay, so factor out a y prime here. We got 2xy plus 2x to the fifth y cubed minus x squared. Okay. Okay, so Now, what we're left with is, if we divide both sides by this term, we've got okay, and I am missing a term here. I didn't see, I left out this y squared, so there needs to be a y squared here. Okay, so this also includes y squared, and that is y prime. Okay. So we've got okay, chain rule here. The derivative with respect to x of e to the something is what? It's e to the something times the derivative of that something. What is the derivative of x over y? We need to use the quotient rule. So the derivative of the top, 1, times the bottom, minus derivative of the bottom, times the top, all over the bottom squared. Okay. Derivative with respect to x of x is just 1, and then we've got y prime here. dy, this is just dy dx. Okay, let's just solve for y prime. So what we have is e okay, let's cross multiply. So we've got y squared minus y squared y prime is equal to y e to the x over y minus y prime x e to the x over y. Okay, let's bring the y prime terms to one side. So we've got okay, so now let's factor out a y prime. Okay, so now just divide both sides by this term here, and so we've got y squared minus y e to the x over y over y squared minus x e to the x over y. Okay.